Ooh, we're streaming. Does it mean I have to do stuff and show stuff? Probably. Welcome, everyone. Welcome back, Martin. We're probably going to watch this. Nice to talk to you again. Really cool. Very positive after these other experiences I had with so-called supporters who were not really supporters. Only one guy. Greetings to the former interns. You did a good job, but themes have to be changed sometimes. So, yeah, let's try to make this actual algorithm. I don't really care anymore if people see the algorithm and copy it. I don't care anymore about keeping it secret, I think. Not at this point, really. So, keeping stuff secret is like work. And the positive result is I can stream on YouTube again, publicly. The algorithm is called Corridor. I invented like 2 trading algorithms. I think one is much more typical, like existing algorithms. It's called Chaser. Chaser is for big movements. It's like scalping. It tries to see spontaneous moves that look like they go on. They will keep happening. Moves in the crypto price, and it just sets a position to follow this one move as far as possible with the biggest leverage possible. So it's for big moves, which are kind of spontaneous. And the other algorithm is called Corridor, and it's the exact opposite. Corridor looks for small movements that occur all the time. And with each of these small movements, whether it's up or down, you get profit. It has one fixed profit amount that you get for each of these moves, which depends on how much margin you have, how much money you have to move around. It's a bit complicated to find out that part, but the algorithm itself is pretty easy to understand and predict. So it follows these small movements, and if there's a big movement that's multiple times bigger than this small movement, then the algorithm is not as happy and actually has to pay for it a little bit. So the way it works is that the algorithm makes a bit of loss when it expands its corridor. So let's check the actual examples. So futures. Here's good old Bitcoin, although I really don't want to start with Bitcoin. I don't know. Bitcoin, the great grandfather of crypto. Maybe start with Ethereum, although the curves are pretty similar, usually. So you have the small move amount, which you define as a parameter for the algorithm. Let's say the small move is 0.2%. It's basically the smallest move that makes any sense because there are fees and everything. So when this goes down, for example, from here to here, oh no, actually, there's not much movement here. Let's go to another scale. So here, 0.2% is from here to here. It's not the best example at this point in time here. Well, anyway, with each of these small movements, you make money, and you define the capacity of the corridor, which is how many of these small movements are stacked, and that forms the corridor. So you may have 0.2% for one step, which I call also a cell, and you may have 5 cells. So the width of the corridor is 1%, and the width of each cell is 0.2%. So the corridor starts out as being nothing, basically, and as soon as movement occurs, it expands. So if the crypto moves upwards, the corridor will expand to now have a capacity of 2. If it goes up again, the corridor will expand again, and after it's expanded, it stays that way. So if we have a corridor of size 3, the crypto can move down again within this corridor up until the lowest point, which is the point we started with. And we make profit all the time. And if the price goes outside of the corridor again, we have to extend the corridor. And the thing is, extending the corridor costs something, and it gets more expensive the bigger the corridor already is. The corridor is already 5 units high, and we expand it one time more. It's going to cost us 5 profit units. These are the same profit units that we get for each successful position, for each small move. So it's a trade-off. If you have a bigger corridor, you make money all the time. But if the price actually goes outside of the corridor, you will be in a worse position because the corridor has to be built again in a new place. The ideal position you would want to have is to have a huge corridor on one coin. You paid the price for making this corridor earlier. It has amortized because it's generating profit all the time. So after some point, it will not make any more debt. It will only make profit, and then you have the best position. You can say, whatever Ethereum does, it will always make money. Except when it stands still, then I am plus minus 0. Yeah, that's the algorithm. I'm not sure if it exists. I'm just reinventing something. I haven't seen it before. I recently learned what grid trading is, and it's somewhat similar. It does the same kind of structure, where you have a minimum price, a maximum price, and a number of grid cells in between. But grid trading is usually in spot, not future. And it's overall just not the same thing, I'm pretty sure. Either way, I just like this algorithm, and I want to realize it. I've been testing it on paper. It seems to work out fine. But it's not connected to the actual trading platform yet. Yep. This is running on my PC. That's my current funds. We can transfer the funds now. Just some really cool new feature. Let's say we transfer $6.41 from future to spot. We get this very refined message window. Note the question mark here in the raw JSON data. But you can read it. It says success. And this doesn't reload immediately, but if I reload, I see $6.41 have moved to spot. Alrighty, so yeah, I thought about what I should do to my programming language, which is the scripting language we're using here. And I should do lots of things. I should also do lots of things to the user interface. But each of these things costs us time, so I narrowed it all down. I will only add one function to the programming language. This one function will make making these projects a lot easier. It's absolutely crucial. It's just the ability to define a function that is visible in the whole project. So normally, if you define a function, let's see if this was saved or not. Yes, it was. Oh yeah, I shouldn't add it here because this project will be overwritten from the server. I do all the editing on the server because this can be downloaded by each user instantly. So that's why we distribute new versions of the bot. In terms of users, we have 1 user so far. Me and another guy, so we're 2 people. But more may become. I also researched chatbots. I made chatbots for so many years, I cannot get the word out of my head. Trading bots. I researched trading bots on YouTube, like people sharing their experiences, and the experiences were positive. People actually make money. One guy made 10% on his money in weeks. I forgot what it was. No, this was a week, actually. I think it was 1 week. So the profits do happen, and we have a fighting chance here, I think. It's not generally unsolvable, as some people have claimed. Okay, if we define functions, we can define functions. Find this marvelous function here, and I can call the function in the same script. However, this function will not be known elsewhere. And what I want to build is some standard functions related to the trading. So I can write proper scripts, easy to read, easy to maintain, and everything. So I propose something like The short version would be export function. This that would be the short version, or not the short version. That is the like a base level. How I tell the system that the function is globally defined. Then we could have some shortcut, something like export def, which will automatically export this. But first we need this here, and I'm going to code that right now. Right now. So it's per project by default. Export functions. Probably could go in here. Or utilities class. Because somewhere we make our parser. We want in every script that we write in this project, we want this function blah to be known. So it has to go into the parser that we make for each script. And that's actually being set up here. And yeah, we just put in some functions here. At the end, probably. So we collect our function definitions in some structure. Yeah, the parser itself has a map with the name of the function as a key and this function depth object. And we need something that is searchable quickly, so we need the map anyway. Yeah, I'm thinking we can just put this in there. Another option would be to make one prototype parser that we keep around and clone this parser for each parse. In fact, that's actually done, I think. Prototype parser, yes, it's true. Okay. Aha, copy function containers run. Yes, but after that, this is just for function containers. What's the order of execution here? Yeah, no, these are executed every time for each new parser. We don't have to worry about the order. So here, yeah, we'll add some function definitions. There's some function for it. I don't think so. Okay, we have a lookup function here. This also looks in local scopes in the script. We just add one map to the other map, that's all I think. I mean, you can have a function here that's kind of cleaner. Add function defs. Let me say put all. To copy all the elements. Other add function defs. Project-wide functions. Function defs. Basically, it doesn't matter if you put it here or in the project object. It's a one-to-one relation usually, yeah. Map. Let's make it a synchronized map so we can add concurrently. PDF, and then it's actually contained in this auto class. Oh, yes, it's in the script, not in the parser. Find external object. Let's make a new field for this. Let's have the parser also know functions. Function. Yeah. So when the inner checks fail, we check the outermost scope, which is the parser itself. So we just query this map here. Okay. So we copy this definition here. Looks good. That also looks good. Oh, we didn't make the other method yet. Export function also needs to go in there. This goals list is subject to change. It's more a rough guideline. Oh, I interrupted the compilation. Now we will not know whether it compiled or not. Compilation failed doesn't mean anything if you're interrupted. So let's do it again. And at the same time, put in the next function. Export function name and function definitions. And we simply put it in these project-wide function definitions. However, we should also make some kind of trigger so that everything is recompiled or marked as needing recompile. Scripts that already run, I think we won't change those. Yeah, I think we just say from now on, every script that already has been compiled, if it gets requested again, please compile it again, because new functions may be available, or replaced functions is maybe the more important part. Function with the same name is replaced. So when we have something like that, we also do this when new classes are loaded from some library. And I just have to remember what it's called. Yes, it's called new classes defined. And the name is not quite fitting, but we can use this same function. Make sure all scripts are compiled. Scripts are forgotten. Yeah, time to be brave. Recompile the main program. Yeah, about the goals here. All tickers, yeah. Ultimately, the bot should show all 80 something coins in one place. Oh, hi, Leergut, who are you? You someone I know or I don't know? Or anything in between? I don't know. So, yeah, show all 80 coins in one page. That's going to look cool, A, and B, it's pretty useful. Because you could sort these tickers then by trading signals. So you see the coins that are best to trade right now, as seen by the bot on top or whatever. But I want to get results quickly. So the first results are going to be one algorithm on one coin. So I'm kind of postponing this stuff about all tickers, etc., and all the UI. Maybe I just make a script that works for one case. I just want to get trading. I want to see the first algorithm actually trade on an actual coin. Maybe a demo coin, but maybe even a real coin. So I'm going to postpone everything that is secondary to that goal. The function def, it needs to be imported. We could actually do this globally here. A little bit of JavaX magic replace. No, delegate function def to this outer class. And there we go. Yeah, so now I gave away the secret to my algorithm. Oh my god, how can we do this? Okay, export function is now not marked anymore. Oh yeah, but this, you can't refer to the function actually. I thought it was possible, but it seems it's not actually. You can only call it, but you can't refer to it. I do want something like this because it allows you to export functions programmatically. Yeah, we need some syntax to find the function, or maybe no syntax. Should just find it. Yeah, let's make a test. Def blah x, and even have something simpler. Just a dummy function. We def function definition, and then we just return. Okay. We do need a special syntax because this could mean calling the function or returning it. Yeah, let's also have something like current scope. So, yeah, let's see. Oh, what does this definition return actually? Maybe we can have the function definition return the function object in case it doesn't do that yet. That's elegant actually. So I do just this, and what's the return type? It's null, but why does it have to be null? It could be the function which we just defined. So we can test like this. F is the function definition, and we assert that F is do it outside of the script image. Okay, left arrow script. This. Third instance of function definition, right. You could ask something like, the name assert equals blah. This should be name, however that is implemented. Dot name actually. That's def returning a function def. Okay, now this test will fail, as is good in test-driven programming. And after the test fails, we are allowed to program something. In test-driven programming, you are only allowed to code something for your program if a test failed. That means every functionality basically is tested. It's very funny. It's actually a very good methodology. Perfect, but sometimes you just don't have the patience or the time or the money for doing this extra step. Sometimes you just revert to writing a simple program. Ideals are not always the same as what you end up doing, or it wouldn't even make sense. Okay, I just made a little typo. It should be this. For my scripting language, I use test-driven development actually, because it has to be stable. If you make a programming language and it's not tested, you can't really, it's unmaintainable. If you introduce changes, it will break something, because programming languages are just so complicated. So that's why you need the tests here. Yeah, it's not a tiny problem. Oh, please, please, please compile. What did I want to do here? Oh, here's why I didn't. Okay, here's why I didn't make this change. Maybe not. Parse function definitions. But the function definition is not a statement or an expression. Okay, this is our failure that we wanted. The function definition returns null instead of the function definition object. Where is this called? It is called in, oh yeah, okay, it's called in the class body loop. But that's not the one we want. It's passed in the instruction, so we're actually in the right spot. We just want to make it part of the script. So it's only very relevant if it's in an assignment or if it's the last expression. Basically, if you have to return something here, yes, okay, the definition is parsed, but it doesn't return anything. And the other statements or constructs all return something, which is built into the program. So that's what we need to do here. Why can I not keep pressing Control Home or whatever? Here. So we need a variable that is a function definition. Okay. Which is actually just a constant. Yeah, okay. I'm beginning to see the trees among the forest. Parse function definition returns the function definition already. Okay, we are not using We are just not using the result. I think this is all then. We have a constant. Returning the constant is the program. Yes. Yep. I think it's sound options. Persist the strategy. Yeah. We're talking about 24/7 operation for these bots. So if you plan to run a trading bot, we can have the trading bot also chat with you. Hey, I made some profit. Hey, I need more money. Hey, I'm offline. What are you doing? Yeah, trading bot, chat bot. If you want to run a trading bot, it has to run 24/7 basically. With this corridor bot, definitely, because it makes these positions, these long-term positions, which are the foundation of the whole thing. We can add safety measures to them that close the positions when the bot is offline, but these will not be the perfect operation. This will just be an emergency measure. It will break your corridor if you keep the bot offline long enough. So the bot really has to run 24/7, actually. So if you can do that at home, if you have a good internet connection and a stable notebook that isn't too loud, or in the next room, which you have running 24/7. However, I would suggest to use a server. Like I'm renting these are VIII servers for, it's definitely like $5 a month. $10 for the fancy one. It does not need any computation power. It can be the cheapest server ever. Not the cheapest server ever, but as I said, $5 is probably fine. And these are super stable. If I go to the uptime, which I made a nice script for just the other day. Hey, look at me. It's when the coders make fancy fonts. This computer has been running continuously for 157.1 days. It just doesn't crash. And sometimes there are scheduled reboots, but it's super rare. So you have to make sure on reboot that the bot gets back up, etc. But usually they just run and run and run. So this is a very good option for a trading bot. It says, unless you're using standby, because in standby, the uptime calculation fails. It says, my PC has been up for 10.2 days, but I turn it off every night. However, I use hibernation, Windows hibernation, and this gets counted differently. It only counts from an actual reboot. It's not, yeah, you can ask Windows for the last wake up time. I do want to put this in the bot, and I want it to be correct. So right now it's correct if you honor this disclaimer here. Yeah, whatever. People will know how long their PCs have been running, so it's not that interesting, but yeah, we need stability. Bot needs to, like a hen sitting on its eggs. It's to warm the positions and to have them. Now I forgot the word. What do little chickens do when they get out of the egg? Hatch. They hatch, right? Yes, the eggs hatch. Yeah, let's make our eggs hatch. And yes, the test actually runs now. It's a computer's deadbeat way of saying the test is okay. And it may mean that we can now run this and actually export our function. If you export it again with the same name, it overwrites the old one. So there's a fluent evolution automatically. If you restart or reload the program, it will forget all these functions, but you can put, we could either change that. Yeah, you can, the idea is to you put your global functions in one script that you run on startup. You just check this here, run on project open. So you are basically in charge to restoring your functions, but it shouldn't be hard. Okay, now unknown object, but we can say blah equals blah. Okay, now it's not completely working because it's in parse instruction and not in parse expression. We can't assign. We didn't test for this. We tested for this here. Now we should test for assigning to a variable. and do the same test as before. In fact, this line is completely useless. That should be test enough. Now the test will fail. I am probably allowed to start coding before the test fails. I shouldn't commit the code until I see the test fail. Don't flout test-driven development. Parse function def. Yes, we have the error. No, we don't have the error. We have another error. Yes, it's called here in parse instruction. We remove this one probably. Yes, and we go somewhere to parse expression. Here. I think that's it. Unknown object def, yes. New favorite drink, bitter lemon. It's a bit of a misnomer. It's kind of sweet. It's a lot of sugar, but it's bittersweet lemon. That's the right mixer. Sweet and bitter. Enjoy it while it lasts. Economy is breaking down. Food chains will break down. I think the Great Reset is in full effect. We'll have real trouble with diesel engines and cars in the next weeks. Because AdBlue is running out. The additive to diesel that they need to run. I don't know if they can't run without it anymore, or if it's just illegal to run diesel without AdBlue. But some AdBlue manufacturers in Germany shut down because of the energy prices. And it may be a real problem. It's going to be a tough winter in Germany. Food shortages. We'll see. Let's get rich to escape this hellhole. That's our plan. Compiled okay. Exports output null. Yeah, because the export function doesn't return anything. But now, what if we now call our function? Oh, no error message. That's very good. And look at that, it works. We have now defined a global function. What's with all the computation? Okay, that's just what I just did. Okay. We are still logging all the crypto prices. There's a new cryptocurrency on BitGet, which is called football. Names are getting ever crazier. That's crypto for you. How crypto changed the world, right? How crypto changed the world, really. Like so much. In the end, it's a super good thing, actually. Because it's a new kind of money that is super different. I'm not saying it's perfect, but it's based more on math, and it's based more on the internet and more on decentralization than the previous coins. And it changed a lot about the perception of what money is, really. And many other things. And many people got rich. I mean, some people lost their money with crypto. Others got super rich. So we are trying to join the latter train. Yeah, the crypto, I mean, it's super interesting. I wouldn't have gotten into trading probably if it weren't for cryptocurrencies. I don't know, maybe. And they're pretty volatile. And I'm not sure if you do stocks. It was suggested to me that trading stocks is better than trading crypto because we have no fees on some platform. But are stocks as volatile as crypto? Because the volatility is what makes the profit. We need some amount of it to make profit. Can you get as much leverage? Because on BitGet you get this ridiculous leverage, past 100x for many coins. Yeah, getting rich quick. Is it possible? Okay, so that was actually very successful. We could make this shortcut to global live blah. Yeah, let's make the shortcut also. Well, it's a bit of a hack, maybe, but oh, also one thing, we don't have to pass on the name because usually you want to exploit the function with its name. The name is inside the function def anyway. So we have this shortcut here, and then we say it's null, we do nothing. Otherwise, we export it as its original name. Because now we have a really nice shortcut anyway, which would look just like this here. And when we are at this point, we could, in fact, just shorten this function name to just export maybe. Right? And bada boom, we have our language extended. AKA export, and there it is. It's not a global, what do we want? Global blah. I'm all for export right now. Okay. Dunsky, Duda Dunsky. Yeah, this one we definitely need to do. The opening form proposition does not do leverage, which makes it pretty misleading. We can make all of that a part of our newly defined library that we will create using this new structure. The real jump for my scripting language. Now we can use it to make libraries of functions. It's so cool. Okay, it works. Let's checking again. It works. And maybe we want to unimport function. An export function. Measure, and it will return the previously defined function. Project wide function. Let's get remove. Now I forgot how this Java map function works. Does it return the previous element? I think it does. Let's learn Java. Not like I've been doing Java for like 25 years. Still have to look things up. I like how quickly this IDE starts with my new computer. It's such a fat program. It used to take like 30 seconds to start. It's really fast now. Yeah, it does return the previous value. V as in value. So this turns pretty quick, easy. No, yeah, not completely. We have to call this one also. So Okay. What if we want to call the unexport function with a function, not a name? I'm overthinking it. Okay, good. That was that. Now we can define our library of trading bot functions. Let's start with list positions, maybe. Yeah, because that's also a goal. We have to show the open positions in the GUI, allow closing them. Let's save this test. Exporting functions. List positions. Export if list positions. And we actually did something before. Get positions for all coins. Filter out the empty ones. Yes. Yeah, that's our function. And I don't think the script is used anywhere. Let's find out. It's not. So we could basically, yeah, remove this down here. As the function. Function if, that's great. And here now, it should be possible to actually just say list positions. Wow, right on. And finally, we have to make sure this runs on auto start. So we have, I want to make something like -1 here, -1. We have these priorities, and that can be letters and digits, and they are sorted smartly. So if you have 1C and 9C and 10A, then 10A comes after 9C, not before, as it would be in alphabetic sort. So it's really clever, but it doesn't account for negative. You could improve this already pretty smart sorting function to understand negative numbers also. But it might be, you know, if you have a -1, is it a negative number, or is it just something else? So unfortunately, we could go with prio 0. We already have prio 0 though. Damn, I want to go below prio 0, and right now I don't think there's a way to do this. So let's call this prio 0b. Oh, prio 0 is defining the function. So here we are. And we say prio 0. Probably the lowest one there is. Okay. Let's reload the project or restart to check. Not happy. Not happy. Not okay. Oh, okay, so it didn't actually run this properly. That's confusing. It's run 12. it is clear for auto run. Let's say I run this now. Yeah, now it works. It's empty, but I actually don't have any positions, so that's correct. But why didn't it do this on auto start? That's my big question. Yeah, well, ultimately, this should not be in this object. Auto starter. Hmm. Um, I know, I think. Yeah. Yeah, it's only affecting the IDEs. It's only affecting code that you write here in the user interface. It's not affecting scripts that are compiled internally. So, okay, yeah, we need a little change there. Here. I need to make, need to notify this function that classes have changed or functions have changed. Basically, we need to compile, clear the compile results. Yes, forget compile results. Okay, we call this at some point. Could also do something even simpler, actually. I know what we can do. We put a timestamp in this object. Recompile 8. And every script is asked to recompile itself if it is if it was compiled before this date. Does it know when it's compiled? Or not. Results. If not, we should put this information in there. You could swear there are timestamps in here. Yeah, there is actually. Unresult with timestamps. Compile log. Yeah, we just make a querying function here. Compilation starts. File log. Let's start it. Okay, if we have a compile result and It was made after we can put the function if it was made after the last function change. If could recompile. Yes, if yes, yes. There we go. It's a valid cached result if it's still the same script code and it should not be recompiled necessarily. Let it go. And we do the same thing here. I know duplication of code is not good, but it's only twice. There we are. And here we have should recompile. No, compile result. So if we have no recompile date, it's all fine. If we have one, then we compare starting dates. No, we say if it was compiled before the change, please compile again. Now we set this recompile date. Actually, and we do it in wherever it was. No, that's just the interface. Oh, it's in here, yeah. Yeah, no, I can do it in all loaded projects. Why is everything always so complicated? Yeah, so the recompile date maybe goes. No, I like it here also, so. It's called only here. So let's make this one's okay. Let's change this one. New functions defined. Recompile date is now. Right. Okay. Okay. No need to change this. And hope for the best. And show you the corridor code. Yeah. Cell size, as discussed, is a percentage. Although that's not actually implemented yet. Oh yeah, there's no price cells. Yeah. Currently have a linear grid, so every step is the same. But I want something like exponential. I want every step to be 0.2% above the last one, but the next one should be 0.2% above the second one. So the distances increase and the price gets higher. That way you could theoretically cover a coin that goes between $1 and $1,000 in price. because the algorithm adapts its cell size as the price increases or decreases. I want to have the actual pretty much perfect version of the algorithm when I actually start to use it. I want to add this thing with the exponential cells because I just want to have it running on one coin. And even if the coin does crazy things, if the coin crashes or if the coin goes to the moon, I want the algorithm to still work fine. And that means making all the parts of the algorithm. Okay, something here. Should recompile. So it's telling me this is not legal Java. I say it is legal Java, so please go away. Okay, it's not legal Java. You spot it? There. Okay, computer was right. Computer isn't always right, contrary to what some people say. It's garbage in, garbage out. Bad program in, bad result out. With perfect programming, computers could maybe be perfect. Okay, so this regular intervals, I want to change this into exponential geometric, like geometric series. Series, yeah. But I mean, who's going to understand this geometric by cells? How about what did I say? Near intervals, exponential. Is it exponential though? I'm feeling fancy. Let's call it geometric. So this here is the, I love percent stuff. Let's say percent increase. Stays. That's a really speaking name. Cell size in percent. Okay, now it gets interesting. How do we implement this actually? We need a logarithm to a certain base and the exponential form, exponential to that same base. Yeah, it's going to be a bit of math. We can do that, can't we? What's happening here? Okay, G22 utils. I should really unify this code. If compile result valid, there. This simplifies nicely. Right. Yeah, we need a logarithm. It's going to be interesting. Our base is 1 plus the percentage. That's the base of our logarithm. Why doesn't this compile, please? Let's start it. Yeah, it's a function and not a field. No, where is it? Here. It's gotta work now. Come on. Still? What? Oh, compilation's done. My bad. Yeah, I don't have the best autocomplete in my editors here. It's because I made my own programming language. Which sometimes, yeah, sometimes you pay a price for this. The gains were worth the price. Wait, what? I just changed. Oh, oh man. I changed it once instead of twice. Okay, please now compile so we can go back to teaching. So if I have 0.2% is my cell size. So, yeah, what about the script now? Still not happening. What's happening there? Let's check the function. Function. Project wide. No. Project wide functions. Function defs. Like this. Oh, it's not in there. That's confusing. Oh, we need like an auto start log to actually see what's happening. And how about we just print every function that's defined? Find function and undefined. Doesn't work now though. What if I go here? Almost done. It's almost done. Anyway, we have cell size and percent. And one means the auto start is still running. It should show like a progress bar, actually. Should put that in. 0 means it's done. Still empty. That's really strange. Run it. Now I have this in here. Maybe prio 0 is not the right thing. But shouldn't matter. No. Strange, strange. Okay, let's fix later. So the ratio is 1 plus this percent divided by 100. Yeah, that's our ratio. Let's say we start with 1,000 as a price. Then we can say ratio divided by base price. But we can always do divisions, or we can do minus on the logarithmic scale. One is faster than the other, but basically nobody cares. What am I doing? I want something like, if we have 5 cells, what is the price level of each of these? If you start with base price. If you do only one step, it's easier. Yeah, we want to implement this function, which is called next cell limit and is cell limit. Definitely, we need this logarithm with a base here, d and base. Our base is this ratio thing. And then from that, we subtract the logarithm of the base price, actually. And then we have a number that we need to discard the fractional part of. Basically like this. Oh yeah, we just transfer. Yeah, we go to the log scale, and then we do the same thing as we did with the linear cells. That's actually the way, yes. Remainder. Yeah. Or I can copy and paste different machine. Okay, we have two logarithmic scale, two log scale. That is this one. Yeah, and then we have from log scale the opposite. That is exp ratio price. It's the exponential. Or x. And then the rest is the same as in the other function. Remainder price is yeah, we could recalculate this logarithm of the base price and price minus base interval. interval now actually is 1, which makes it easier. So that's just a fraction. So this would be remainder price plus interval minus remainder. Plus 1 in this case, minus remainder log scale price. And we have from log scale afterward. From to scale, what did I do here? From log scale. Let's see. Next cell limit 1000. It's called pow or power, not expert. Okay, that looks completely wrong. um, yeah, let's do 2 steps. Log price. Here we could also say log price, so we don't need the comment. Much better, log price, and then from log scale. We need a log price here. And log price. Okay, but that's not 0.2% above 1000 for sure. Doing something, but not the right thing. Let's try something simple, like from log scale to log scale 1000. That equals 1000, but not completely rounding. Yeah. Okay, it all works except for some very small rounding errors. Works. What's the problem here? What's the remainder? Okay. What's the log scale value anyway? Okay. Yeah, because our ratio is so small, get pretty big values. So the next one we want is 3, 4, 5, 8, right? No, not necessarily, actually. This is our base value. Log base price. Oh, call the log function, not the. Okay. Okay. Okay, I think now we're better. Yeah, 1002. See, it's 0.2% above 1000. Go here, get 1004, dot a little, compound interest, if you will. If you go to 1100, you get a bigger increase, and if you go to 10,000, it actually adds Ah, yes, sure, because, yeah, I thought it would be around a number, but it's actually correct because we're using a certain base price. If you go one more, yeah. Yeah, here we see an actual 0.2% increase. Yeah, that's actually our thing here. This is the correct logic for geometric price cells. And if I now download this training bot to my machine, using this one cool button, I'll get this latest code and I can copy and paste it. There. Really fast update. And I can just go here and copy and paste into here. Yeah, rounding problems, I think they are a thing. You need some little epsilon to consider very close numbers identical, actually. So here we go. Dev. Convert to Java. Make the names a little better. Ratio, where is it? Recalculate the ratio somewhere. Yes, here it is. There's that. There's this function. Log base price. Oh, it's only called base. I like base price, actually. We have this remainder, which is only a little different. Do fix this logic's rounding problems. And here we add we add this log scale transformation. First we go to the log price. And then we go back to the normal scale. And something similar for this other direction. Now, actually just this. Maybe some parentheses. Not technically needed, but this is also wrong, of course. Do the same thing as before. And then we have this, and this simplifies. And finally, this function here. Hmm. Yes, understood. Files. So let's test it out. Yes. Class. Click Add Class to add class to your program. And have enough class. Can you? Yeah, these are the same numbers we just saw, but they're now coming from the Java class. Nice, nice, nice. Let's check log to see if our function is finally defined. Oh, it's logging all the. Oh my golly! What? Why is it doing that? It shouldn't do this on this machine, I think, because we have a separate project for the tickers. Here, let's save this one here. Test geometric cells. Why is my function not being defined? Hmm. It'd be nice to have some log of what actually was run. Seems it only counts the scripts that were run. How do I find this problem? Make a test project just for this problem. Here. Function hello gives world here. And it's supposed to run on project open. After I run it, function is defined. After I reopen the project, it is defined again. So this works. Okay. Uh-huh. Okay. I'm doing the same stuff here. Maybe prior 0 is actually the problem. Don't tell me that's the reason. Okay, yeah. Oh, what? Wow. But that's impossible. Why would 0 be a bad value? We're just searching for the check mark. Run on project open. Then we sort, but it doesn't matter if it's a 0 or a. Oh wait, we do have a list of scripts. Here, yes, we have those. Okay. You can see which scripts will run auto starter. It's here. Yeah, we can do this, sure. So say auto starter scripts. Okay. This positions was run last, and it doesn't matter if it's run last. What matters is that it runs. What if I put my prio 0 back in? Oh my god, prio 0. Okay, reopen. Yeah, now it's at the top of the list. I mean, it doesn't matter, does it? Okay, now it all works. Am I crazy? Am I crazy or what? No, that works. Okay, fine. Good, 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 good. So the corridor algorithm takes a price digitizer object, and this one has a left reference to the price cells. And there we can plug in these regular cells, which are linear, or these more real-world usable geometric price cells. However, it creates the digitizer object itself, I think, so that should change. Yep, you can just change that in here. Make it pluggable. Come on. Make nice cells. Make price cells. Solvable. Price digitizer itself doesn't care what size each cell is, or they're all the same size or not. Digitizer quantizes the price changes to the defined levels. So only when a level is crossed, it gives us a new price level, exactly that new level. And it ignores all further changes unless it goes one level down or one level up or more, then it gives us that next level. So the outcome of the digitizer is a very simple, clean digital price change. That's what the algorithm works on. You can at a later point even change the cell sizes. Theoretically, the algorithm is not quite adapted for it, but it's possible. So when your corridor is established on your crypto coin, you can still modify it afterwards without destroying the corridor. Actually, you can make the cells bigger or smaller, as I said, theoretically. Okay, so list positions, nice. You can turn all of these into functions. This discloses all positions at market price. Each and every, no, just for one coin. It's true, yeah. We can make lots of little functions for converting things to each other. That's going to be fun, actually. Let's put them in one script, maybe. Or I don't know, actually. One script of many. Let's make one script for all the smaller stuff, helper functions. Or trading. Run on project open, priority 0. For example, def coin to market name. That would be coin and USDT. Except when it's a demo coin. If is demo coin. And we have a fixed list here right now. It's SBTC, it's S Ethereum, and it's S Ripple, I think. Oh, US, actually. However, we actually have a list of it. We could use the variable we have for this. So it's demo coin. Then we have SUSDT. Otherwise, we have USDT. Cool, and these are all public functions. So cool. Let's run. And the log should say functions defined. Oh, the log just says this here. Okay, this is the next thing we should fix. It seems to subscribe to all tickers, but we don't actually need this because we have this external project that gives us the tickers here. So script 357 is not giving the right answer. It is, however. Oh, one more thing, let's put the log up here. Clicking on the log, having the log in a separate window is kind of pretty annoying. Let's have the log as a tab. Log is Mm-hmm. Oh, it doesn't exist as a class. Well, other time. Sadly, other time. Okay, that's it we do. This function should also be in our cool function library. Let's just call it helper functions. External ticker project. Yes, external ticker project. Let's test it. As external. It's not in the autocomplete, but that we can change also. Yeah. Wait, this says to do, so does it mean the function will fail? The test will fail? Mm, Seems like a complicated test. Yeah, I want to have this in autocomplete. Our new global functions. If they're not in autocomplete, it's going to be annoying. Let's put them there. Oh, it doesn't even compile. What appears this was never run after I put in this new test, which also itself says it's not ready yet. Okay, autocomplete. Global functions. Other add function. Other function that's. Wait, we have. Oh, this export thing is here. Oh, whatever. Hello. Leave it completely empty, doesn't matter. And we make the autocompleter. Give it some text to work with. Just maybe HE. And then we sure the word hello is in there. We get the completions. Assert contains completions or not. What is it? Oh, is it working? Oh, completions actually is the list of strings. Yeah, I think it's a list of strings. Yes. Oh, everything is always so much work. It's probably a feature of this world. Creating equals effort and pain. Creating a baby, well, the first part is fun. Delivering the baby is painful, I heard. Creating something big always seems to involve some pain and a lot of time and effort. I think in heaven it's all different. But this place here where we are, creation takes time and pain. Oh well. But the results are often very satisfying. Where was this other error? L of L. Weird. Yeah, the best algorithm is actually done. The case when the price goes out of the price range and like moves a lot, that could still be optimized. Because I think the algorithm is wasting money when there's a big change. It always tries to build up its corridor again, but fails because the price rose even more or fell even more. So it should only start making a new corridor when the price has kind of stabilized, when it has pulled back actually. Okay, now the question is, what the heck is this thing? Where could it possibly be? Well, we will find out. Yeah, and this is the funny part about the algorithm. It opens two positions when you start it. It opens a long and a short immediately when you start the algorithm, which sounds nonsensical, but it's actually the key to making profit as quickly as possible. Because one of these is going to be closed with profit. That's obviously good. The other will stay open. At that point, you're still plus minus zero, but then with further movement in the price, you begin to make profit. You make that profit earlier than as if you had not opened these first two positions, which is another option. Is it in this one? Where is the error? Thinking it's this one. An error reverse. Yeah, it is actually. Oh, length of iterable. Okay. I think I stopped this one because it's not very good. Yeah, if you have something that's iterable and not a collection, you can't actually take its size. So this should not be like that. So let's say list. And of this list, we can take the length easily. Okay, yeah, that had to be fixed. Now, hopefully, no, I didn't change the autocompleter. So I have to do that. It surely does function depth already, or no, does it not? Okay. Yeah, it goes into global method names. Yep. Surely there we can watch in global method names. We have the parser object. Okay. Do they have to be sorted? I don't think so, actually. But we might want to have them only once if they appear twice. Yeah, hello not contained. Very nice. Here we get all the standard classes and everything in our autocomplete. A super long list. But we do not get hello. Wait, but why is it showing us random stuff like this one? Is the test wrong? Yeah, the test is wrong, actually. We test for HE and line feed. But of course, what we want is the completion after just the two letters. HE. Get map. So it means we have this. We add it all here. No, like this, it's a function method names. Yes, that's it. And we add all the function defs. Keys other.function defs. Error, but that's correct. See, and it gave us everything with HE in the name. Helpers, hex format, headless exception, matcher because HE. So autocomplete working fine, but it didn't give us the function we just defined. But now it might do this. It draws in basically the whole scripting language stuff and everything. Big stuff, so that it compiles so slowly. Okay, test succeeds. Now this autocomplete should give us the function. And I have some cake. We got some cake. Still booting. Hmm. Hmm. Oh yeah. We didn't. No, we put it in auto run. Yeah, but it has different versions. We didn't clear the latest version. Save, clear, and run, actually. Save, clear, and run. And now it's defined. And now, yay. Right on. Excellent. Function name completion. Okay, has external ticker project, so we should not have Here, this is the ticker data coming from Bitget, but it shouldn't subscribe to this because of this here. There's prio 1e, so it should run after the prio 0 stuff. So actually here we should be able to say as external ticker project. Save. Not cleared, but that's okay. Let's restart everything. It seems like this time it's not doing this. That's good. That's great, right? Yeah, I'm not seeing this ticker data here. That's good. Okay, list positions. Okay, where's our next step? Yeah, I want some function to find the live ticker for a coin. My noise reduction AI filters eating noise. Oh, I can see it down here actually. Do the test. Let's test it. It works. This AI is pretty amazing. Crisp AI. It expires. My subscription expires in 2 days. If I pay another $12, I can continue to use it. Not cheap, but cool. Yeah, so the question is, if we have multiple coins, do we make one variable for each of these? Like you see here, do we have one variable that for all the coins, which is a map to the data for each coin, etc., etc. Unclear. Does not really give us anything. Apparently something. Yeah. Hmm. Yeah, we need to follow this ticker file. All the ticker data is written into files, one text file for each coin. And we tail the file so we keep up to date on additions. It seems to be done in multiple places. We should do it only once. And we should make a class for it, I think. Ticker. Oh, this is good cake. It's not bad. Okay, first function, it returns the location of the ticker files. Um, this one here. Tickers there. And now this one already simplifies. Well, in fact, we should call a new file, convert to a file object. There file tickers there. Yeah, everything nicely simplifies. And this one actually grabs some history. Pretty cool. We can use this here. Yeah, we should put it in this object ticker sequence. Our go-to object for crypto price tickers. So basically this we put in a class, I think. Hello ticker. Hello. Oh, of course I cannot copy and paste. But I can copy and paste from here. Oh, we have a file. And we have some kind of start function. And we have this parameter, how many historic ticker entries we want. And we load the historic parts. Yeah, we have a process line function or something. Uh, oh yeah, let's say on historic line. On live line. Like anything that comes in after you start the whole thing. Mm, And this whole thing should be closable cleanly. So we save this object. And upon closing, we close the whole file operation. Mm-hmm. 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 Huh? Storyline. Yeah, function is storyline, yes. Lifeline. Mm-hmm. File interval position on the file. Int long. What? Oh, L0. L0 means has no arguments. L1 means has one argument. Okay. Cool. Another nice utility class. Yeah. Pick a follower for coin. And we put this in a map. Yeah, two functions we can do. Ticker follower map. That's for map for each coin. Assistant. Nope. Transit. What? Wild West, baby. Gotta create hold transient. Pick our followers. Where is this used? npm, this is so old. npm. Where's this error coming from? npm. I don't know where this error is coming from. npm in Gazelle. This, okay, yeah. Okay, I'm still using this somewhere. Why is it compiling it even? Apparently this one, oh, the script is used somewhere. Okay. No, not really used anywhere. The way we can clean this up. Also known as deleting. Just to not to have this one exception. It doesn't hurt, but okay. Have I saved these? Nope. Pick a follower for coin. Okay, I wasn't complete here. So we have the follower map. We once again use get or create. And make an entry for a coin or retrieve it. Coin. So we are making new follower. Follow pick a file. Oh yeah, and this interval is of course a parameter. Interval. Not actually. Yeah. We already have a shortcut. Skip this if we want no history. Oh yeah, time for new functions. Pick a file for coin. Latest sticker file for coin. And that is also already done somewhere. I love that we can make these functions now. Allows for proper software architecture. All within the scripting language, so no Java compilation, etc. Now the variable overrides or shadows the function name. I don't think it's a problem though. Not in this moment. Could be. We can just use, yeah, we don't need a variable. Here the coin is always a parameter here. Market, we can do the cool function above. Market. Yeah, coin to market name. Perfect. Before I could define these functions, I would have lots of repetition of code fragments. Now I do not have that anymore. Yeah, latest. Okay, we're going here. Latest ticker file or coin. Yeah, and one more cool thing, maybe if something in the project variable changes, I would like to have it saved to the database automatically. A bit of magic there. Let's do that also. This is our interface, something that can emit change events. Big chunky name, but that's the one. Yeah. Oh, yeah. Similar to the all close, another magic mechanism. Although I may be a little lazy here. Also, in this case, we don't actually need it because it's not persistent. Its followers are transient, not persistent. Okay, it doesn't matter in this case. Yes, add this class. We're assuming that the file is already there. That should be fine though. Oh, I stopped the auto run. I shouldn't. Okay. Pressing the control key stops the auto start. It's a safety measure, but maybe counterproductive. Okay, where's our last function here? Oh, it's not exported. My mistake. Pick a follower for coin. Yeah, let's say, how about Ethereum? Ethereum fails. Let's go one step shorter. Latest figure file. Coin. That's a real file. It's good. Oh, Sort of a brain fart there. Okay, we have this follow file. Follow, whatever. It should be, in fact, same object. Yes, this gives us the object address, basically. If I run this twice, I get the same thing, so it only makes one of these follow objects, which is cool. Uh, let's launch one thing, auto close. Clean up, yeah, okay. I'm just checking something. Yes, I can put a map as a project variable and it will clean up things inside of the map. So actually here I can say get or create get or create auto closing project variable. Okay, now this will be cleaned up properly, as it should. Yeah, and then we should have something like the latest ticker sequence or live ticker sequence. And once again, we do 2 steps. We make this map live ticker sequences. And we make 1 object per coin. And this follower should put new entries into this sequence, the sticker sequence. That's the whole idea. Put this over that, and this is basically an empty ticker sequence, which we can fill with a name, probably. Market. So it's identifying itself, basically. And in here, we have a listener on historic line. And the parsing is in here. No, this makes the ticker file. Here, that's the one. It's not so hard. Parse JSON, and then we have best ask and system time. We may as well put this in the ticker sequence. Oh yeah, and it should have one more thing. Should have the latest price edit. If the price doesn't change, yeah. If for some reason the crypto price for a coin doesn't change over 5 minutes, which is super unlikely, but let's say it does, we should still know that we have received ticker data within the last 5 minutes. We should have the date of the latest price of the latest ticker event, even though the price may not have changed. So right now we only see the changes here. So last ticker event. Times the last ticker event, even though price may not have changed. Ticker event. Oh yeah, and I want to do the JSON parsing here. Where is it? Yeah, I found it. First line from a .ticker file. Yeah, I'll make it no, it's not the right one, but similar. Add price timestamp. Oh, cool. Oh yeah, add if price changed actually. Oh, true, yeah. Add if price changed only. Oh, 2 hours and 30 minutes. Streaming. That can also be simplified now too, as external. Yeah, everything simplifies. Did I just restart this, compile this? Oh, I didn't even complete the code. Oops. Yes, live ticker sequence for coin. Coin. Yes. Add a JSON line. It handles exceptions automatically. These event handlers, event listeners, they always catch exceptions. So if this JSON parsing fails for some reason, the world will not end. In fact, we do the exact same thing on live lines. So we could say on any line, on line, line, on live line. Okay. It's ID of 1 actually, because there's no return value. Yes. I think that could be it. Now we maybe get our live ticker data. Oh, the algorithm. Yeah, I should start with the demo coins for sure. So SETH. I'm a genius, thank you. So you're not the other guy who's always mean to me. That's good to know. That rules out one person, I think. That person would only call me naive and whatever. And the new thing is called live ticker sequence for coin ETH. Okay, it's empty. Oh, it's there. That's good. It's empty. That's bad. Okay, that's the part that doesn't. Ah, no, yes. Okay, I have to call this once to the following starts. After that, this will fill with data. No, it does not. Oh, I think there's something called start, which we actually should. I think we should call it. What help? Stop it. Get some help. No, start it. Follow start. And we want to return the follow also. And we could actually. No, whatever. Let's do it in 2 steps. Could remove the old follower, which is broken. So we could say get project variable. We can also just reopen the project. See, first it didn't compile, then it defined the functions in autostart, and now it compiles. And we have data. Eight price changes, 12 price changes. Ethereum is live, ladies and gentlemen. We have Ethereum data. Last price. Latest price, last price. Yes, Ethereum data. 1330.4, and conveniently we have this window open and it agrees. It agrees on price of Ethereum. Yeah, we could draw some candles, but it takes time to code that. Yeah, I'll show you this nice feedback I got. Thank you so much. Or we could skip the candles and just run the algorithm. We can always simulate it first. So we have our ticker sequence here. And let's make the algorithm. So we need cell size and capacity, or we keep the existing cell size and capacity. Let's define one because we might want to test with really small cell sizes, which are not practical, but they're good for testing. So let's say 0.1 or even less, whatever. Let's say 0.1, capacity 5. So the full size of the corridor is it's not computed here, but we should have computation. Corridor, yeah, max corridor size. In percent. Corridor percent size. It's the capacity times cell size, maybe +1 or so. That's not completely clear. But we have these geometric price ranges, so it's not, you can't multiply. You have to use the exponential function. So it needs to be a function in here. Yeah, that's interesting information. How big our corridor actually is in terms of crypto price. So one more function here. Size of n cells. Like we can calculate this here. We just say, I think, yeah, we can do it here. It's not great, but just we take any value, like whatever it is. We go the next cell and we go n cells up. Yeah, it just changes. It would, yeah. No. Yeah, but with the geometric stuff, it kind of makes sense, actually. We can actually do that. I could do calculation of that exactly. Yes. And sell limits up. Yeah, so we have price 1, price 2. Then we have percent as percent increase. Not going to run. Yes, because new function. Okay. Null pointer exception. Oh yeah, because it's not started actually, I think. Digitizer. Yeah, it needs the first price to start this to determine where these price cells are, because the current price is made into one boundary of a cell. It's more symmetric this way and better. Okay, that's for later. Okay. This is the empty algorithm, basically. Yeah, so we have to wait until we have at least some data in it. Yes. Hello, stop me, please stop it. What? It's emptied, yes. If it's empty, we need, yeah, ticker sequence is empty. Basically, you just need to wait a little, I guess, and do it again. But right now, we just exit corridor, and then we can start the algorithm. Yeah, we have to feed the price first. We have to feed the first price to the algorithm, which will create the digitizer. Yes, okay. Here's the last price. Yes, we feed this price. Called start. Let's check it out then. Two open positions, it says here, before it cuts off. So actually it has done its starting procedure. And now we should be able to see the corridor size, actually. Most anyway. Like this. Yes, great. So a corridor with a cell size of 0.1% and a capacity of 5 has a total range of 0.7%. So if the crypto coin chain stays within 0.7% of total change range. The algorithm is super happy. Right. Okay. Corridor width. Oh, and we can make more cool standard functions here, like format a percent value. Well, I wanted to do this for so long. Export def format percent. Is that also already a function somewhere? It is actually. We can override library functions in our project. Maybe we actually don't need to do this right now. Format percent. It's probably okay. Why is it 86%? Oh, it's doing the. Oh, yeah, that's funny. It's doing it twice. Yeah. It's doing the times 100. Uh, so there we go. Okay, that was that. Now we have to keep feeding the price to the corridor algorithm so it can do its thing. Hmm. Live corridor spike. Corridor on ETH spike. Yeah, we need a bit of a user interface. I think I am getting a little tired. I promise live trades for today. I will make the algorithm run live in a simulation on the real prices, on the live real prices. So it's halfway real. And then we just need to have the algorithm notify BitGet of its trades and do real trades. And there needs to be a bit of feedback, because if the position fails to open, the algorithm must know about it, so it doesn't try to close a position that wasn't even opened. And we need to put a few variables in the algorithm, like leverage and margin, basically. That's all we basically need, I think. Mm, yeah, let's make a little GUI. This is a super simple one while I eat some cake. Cherry cake is good. Um, and decide where to start. Um, Okay, let's start with the live price. Coin price. Okay. Price. And then we do some random, some repeat updates. AWT every 5 times a second. Update price. Oh yeah, now we can have a format price method. I wanted this for so long. Define format price. It may depend on the coin. No, actually we can. Thank you. Yeah. I said thank you to this. Nice that somebody's watching. Yeah. Yeah, we can make the number of decimals depend on the number of decimals in front of the dot. But usually I think we can say 2 is okay. Two decimals. Right. Good. Yes. It's the price of Ethereum. Be a little bigger. That's really big. There we go. And then we have the algorithm. Algorithm. Oh, we're getting closer. Getting closer to the actual trading bot here, but I want some. I want some word ripping here. Unedited whatever. Rip. Yes, that's a lot better. Open positions, right? Okay, we're not feeding the price yet. Let's do it all in this one update thing. We can actually simply put the last price in the algorithm. If the price doesn't change, it shouldn't complain. Yes, it should ignore the same price being fed multiple times. Total price. Let's maybe put the price in a variable. There's appropriate brackets. The percentage as starting price is. Yeah, we generally think in percentages. I try to not really look at the actual price whenever I can. So the corridor is defined in terms of percentages, and the profits are defined in percentages. So just right now I'm showing this. We could, yeah, sure, we can. Oh yeah, we could put the percentage of the starting price here. That's one option, yeah. So we can see how it changes actually. That's not a bad idea. It's doing something. Okay, we have debt. Interesting. Let's make this a little bigger also. Yeah, that is of course formatted really stupidly. Oh, and we can have this as a list, the status as a list actually, not only a string. So that is, yep. Yeah, percentage is a good idea. We do the starting price and we show the percentage from that price. And we could also calculate it in cells, in corridor cells. Oh, it's showing all these numbers with these ridiculous these decimals. Okay, let's say format profit. Format profit. We're gonna have these rounding errors because of log and exponential and whatever. So it definitely introduces rounding errors and they show up like what you just saw. I kind of have to use floating point for this stuff. The prices have decimals and logarithm you have to use floating point, I think. But the rounding errors should not kill us actually. The auto start will always take a bit because it connects to bitget. It takes a little moment. Although technically we don't need it in this case because it's always logging the separate process. Ticker sequence is empty, right? No, it's not anymore. And the algorithm should be doing stuff. And the other idea was to show multiple lines here. Lines, corridor status. Yeah, that's better. Okay, and ETH price we had diff from starting price. Starting price. Diff. Auto complete broke suddenly. Why does it give me this one but not that one? I don't know. Go. Nice. Right. Right. And we have current price. Right. And then we have the difference. Diff. Format percent. Nice. Starting price. -1. Okay. Diff 0% and -0%. It's so weird. Floating point distinguishes between 0 and -0. I should really, I think it's nonsense to actually show this minus sign while rounding to 0. I mean, that's just, it really doesn't matter. Yeah, also, but we should format this with more decimals in this case to see what's going on. VX. Then we can actually use as percent increase. No, we cannot. Yes, we can. Here. Okay. Okay. Yeah. What is our cell size and capacity? We should show these. I will actually put them in here, I think. Cell size. Mhm. Um, Format percent, it always, it's not very clever. It takes the ratio, not the percent number. Okay, let's make format percentage. Well, I also might want, oh, we could put the minus 0 thing. Yeah. No, I don't know. Format percentage. Nicely. Max capacity. I want to have a plus sign here, actually. On a double. Plus. And plus. It starts with digits. Because profit and distance differences should be with a plus sign if they're positive. Starts with digits. Yes. Something like this. Good. Add plus if starts with digit. Yeah, so, oh, look at here. Oh, look at screenshot. It has closed one position with profit 1.5 something percent, or I don't know, even, well, yeah. I think one means, I think, just one position. Every position you win has roughly the same profit margin. And I think in the bot internally, it's just counted as one, whatever this one then means. So yeah, but it has closed the first position. That's actually freaking amazing with a profit. Here. And the open positions, they sum up to 0, but there's some debt. So some of the positions are negative, some are positive. In some, it's basically 0, but yeah, you need to take this into account. I think with cross positions, it will be okay. So you can have one position in the minus, one position in the plus. If they add up to basically 0, I think the system will not liquidate. It has to be tested. We have to know exactly when something will liquidate or will not, because liquidation hurts. So far, no closed positions. As soon as the difference here hits 0.1% plus or minus, at that moment we should have our first closed position with a profit. Here, this profit is unrealized though, and it still has too many decimals. Wait, but 3 open positions? That seems too much. Yeah, we should somehow show the actual corridor size. Max capacity is 5 cells, but maybe we should show how many cells there actually are right now. It's related to the number of open positions. You should be able to calculate this from here. And here we can use our cool method add plus if starts with a digit. Yeah, and let's show our actual positions that we closed. How about timestamps? Closing time. Time. We say swappable, so you can put in a real time or some simulated time or whatever. So by default, we use the real time. And when we close a position, we set the closing time. And we have an opening time too. It's surely useful. And then we show our positions here. And we can make the cells really small so we get lots of lots of positions just for the simulation. So if we use 0.01%, we should get a lot of movement. Wait, did it use restart? What? I looked the other way. It did restart because it has this new. No, it does not. What did I do? Didn't I click here? Hmm? Yeah, let's go with 0.01. Really small. Delta is 0%. It's rounding down. Yeah, that's stupid though. Cell size 100%. No. Okay, one closed position. It's closing position, so we should just show the list of positions. How about we fix this also? If it's empty, we sleep for 1 second. It's still empty, we say, oh, that's sad. Within 1 second, it should actually give us new values. Okay, this has to be compiled again. And we add the positions here. Oh, proper cell size. Mm-hmm. Let's combine. Yeah. For the status, and then we have uh, the open positions and the closed positions. Maybe it kind of works like this already. Yeah, it roughly does. Let's put an empty line here and then say open positions and closed positions. Right on. Every time I press run, it restarts the algorithm. So yeah. Okay, apart from this horrific formatting, what is it showing even? Oh yes, it's showing the idealized price, which is just the sell limit price, and the real price that was reached at that moment. So the idealized price is a little different from the real price. I think that's how it works here. Yeah. Okay, see, all the closed positions have the same. Yeah, the profit can change a little bit, but they should roughly have the same profit, which they don't. Interesting. Okay, we'll have to check further. How's the profit calculated? Yeah, it's using the real closing price, which is a little bit different from the idealized price, so they do vary a bit. But they are all positive. Every position that is closed is always positive with this algorithm. That's how the algorithm works. Unless the corridor moves, then it's not like that. Okay. The corridor has expanded, so we have more open positions. And shortly we will have more closed positions again. Looking pretty good, isn't it? Unrealized profit is also positive, even though some of them are negative. The open positions are most of them are usually negative. That's how the algorithm works. Oh, 5 closed positions plus 0.3. I mean, if we had no fees, yeah, this would be actual profit. We could work with a 0.01% sell size, maybe. If we have fees, it doesn't work because the fees eat like, I think it's 1.2% actually. No, 0.12%, right? 0.12% is the euro fees on BitGet. Yeah, this looks very good. And basically, it can't be fake because the corridor, internally, it just simulates opening and closing positions. So it roughly simulates what a trading platform does. And from that, we calculate the profit. It's also simple formulas. So we're not really faking anything. If the algorithm was broken, it would result in us getting negative positions, bad positions. Kind of is basically a proof that the algorithm actually works. Yeah, see, now we're amassing these closed positions. And so far, Ethereum has not left the corridor. We do need, we should show the corridor size actually. Which, how do we calculate this from here? You can calculate from the open positions. We have long and short, actually. Mostly we have longs here. If we have long positions, it means we are close to the bottom of the corridor. Because long positions are bad if you are in low prices. If these are mostly short positions open, it means you're near the top end of the corridor. So basically, we can calculate the size of the corridor by just taking the lowest and the highest price in these positions. That should roughly be our corridor. Plus minus 1 or whatever. Debt, we also, debt, we have a max debt, I think, or we should have. Should remember the maximum debt that was created. That's interesting to know for, how much money you need in the beginning phase of the algorithm or when it moves the corridor to not go bust. Max scene, max debt. Maximum debt scene. So debt. Every time we update the price, we do this. Actually, we need the minimum because that's stored in negative. Max debt. Or we could use a minus here. Actually, we could. I do like it with this minus sign. It indicates something. Indicates a negative position. Yeah, so it's working great here. Realized profit plus 1.3 from 12 positions. Some of them seem to make very small. It's because our cell size is so ridiculously small. So one price change already hops almost like over 2 cells or something. So we get these weird positions where we have almost no profit. This should be absolutely different when we have reasonable cell sizes. Okay, and we wanted to have the corridor size. Yeah. And so we have corridor price range. Current corridor price range, double range. We'll just go through the open positions. Take the opening price. Like so. And we just say minimum, maximum. And then this function here. We take the ratio between the highest and the lowest price. No, percent increase. Right. Increase. Yeah, it never is null, but it could be none or whatever. Not infinity, no. If you take the maximum of 0 values, you get infinity. Or minus infinity. Ah, yeah, I should fix this. This takes a ratio, but I wanted to take... Oops, wanted to take 2 values. EA or AB? Wait, what am I doing here? Higher price first or lower price first? Higher value first. Matter of taste. Yeah, now we can show the corridor size. And width. The corridor. And here we put the percentage width. Percent width. We should format these things properly. Oh, the price formatter is not here, but well. Whatever. Format price. Yes, I knew this one. What did I do with the price formatting? It's format double 2. Okay. We have 3.5 hours. It looks like the algorithm is doing what it's supposed to do. Ah, the error message disappeared with ticker node or empty ticker or whatever. This one, good. Okay, so a corridor is this here, 0.87 to 0.92. It's not empty, it's already a bit of a range. So it means we had one crossing already, which opened this third one, but this one should also close one. Confusing. These first two are the two positions opened at the start. And let's format these positions better. Well, yeah, at this moment, we could also feed it with historic data. See what happens then. I mean, that's definitely also interesting. If we use it live, we can wait forever until something happens. It's a patient algorithm. You run it overnight, and then it will have made some profit, slow but steady. Okay, let's format these positions better. Okay, it's already formatting itself, but we need this format price here. Yeah, and this, oh, the digitized price was not there. Yeah, okay. Because the first two were made before everything started. Let's see. Why is the digitized price not set? Mm-hmm. Yes, okay, you know. Yeah, in the beginning, these digitized prices don't exist. Only after there's some movement, then the digitizer knows what digital price limit we're at right now. Okay. And the profit should be formatted better as well. Format profit. Yeah, that minus 0.5 in some unit. Max that. Okay, great. Why this is greater than this one, I don't know, because that should not be. This, maybe the last that is not factored in. Why is that? What's happening? Um, why do we not? What? How can max debt be smaller than the actual current debt? Minus 0 and plus 0. Fantastic. Okay, reopening price, digitized, none. Yeah, but we need the digitized price to close this. Mm -hmm. Mm -hmm. And we can fake this. I think it's not a problem. Digitize. want to find the closest cell limit here. Cell limit. We go up one and we go down one. We take the one that is closer to the original price. So up stiff price comes one less than X stiff price plus two. Price one, otherwise price two. Okay. And then we can call it here. Here, open collision. Oh, wait, it's even easier because the starting price is the cell limit. We're starting the cells. Okay. With the starting price. So if this is, if it's not a number, we say price is this. The corridor has grown now to 0.1% rounded. Okay. So what if we want to connect this to the platform and actually do some trades, as was promised by someone at some point? Oh, it's 10 p.m. Wow, wowzers. Yeah, so the algorithm just needs margin and leverage. Position options. Leverage is an integer normally, I think. I mean, there's no real reason why you couldn't offer leverage 3.5. Theoretically. I've never heard of it and probably nobody's doing it, but it could be a floating point value. So let's just keep this double. And we have margin per position. Let's assume it's 1 USDT. Just for laugh. It can always be changed. It's the default. Because now we can also connect it to the platform. Let's put the stuff first that the user sets and the internal stuff later. Yeah. So, and we have link to trading platform. We have some other classes already. We don't have trading platform, futures, markets. Nope. So this is supposed to be the interface to one market. Whatever, like this. So we will have open position. Yeah, we have a hold side class also. Hold side, short and long. Open position with a hold side. Oh yeah, the amount will basically be it's fine. This one is supposed to be in USDT actually. And we will use the current price, which we have from the ticker, to calculate the amount of crypto, amount of Ethereum we're betting on. So we have amount here. Amount is in crypto. How about we put it in the name, crypto amount? And it doesn't really return. Does it return something? Well, and maybe we want an object here because there's many parameters. Yeah. There's more or less, there's cross and isolation. Can I put a class here? I think I can. Open order. So we put all this here. Is cross support. Open order. And the one thing it has to return is whether this was successful, is basically the only thing we have to return. How about void, and we just make, we just throw an exception if it failed. Throw exception if order failed. Let's interface, so no implementation. And we need a close position also, which is simpler than the open order. This has just the whole side and the amount. And limit on market. Yeah, it's all market right now. All orders are market. Now, not limit. Okay. Although the corridor algorithm works well with limit orders, or it's at least thinkable. Use limit orders instead of margin to save on fees. Feeling productive today. Oh, compiles. That's nice. Okay, futures markets. Of course, we can have an implementation of this, which is a simulation, and one implementation, which is the actual thing. Okay. 51 closed positions, lots of profit. And as I said, these are real positions, but I mean, real in the sense of could be real. And we have lots more open positions because we have a bigger corridor. corridor, but it should be, if the corridor gets too big, it should actually close some position, and I think it's not doing that. There's 23 open positions, and we have max capacity 5. That's wrong. It has to close links to platform, link to market. Optional. Yeah, what about the closing? Let's check out that part. So here, this closes the winning position. This opens new positions. And this should close parts of the corridor if necessary. It will also be in the log file. Log. Dismantling corridor here. Okay. Interesting. Okay. Yeah, so it has closed bad positions because the corridor was getting too big. But we still have so many open positions. This can't be right. Yeah, they have profit and they're not closed. That's weird. Yeah, we should do something different, actually. We should close all positions that are in the plus, not just looking for one specific one. Yes. Close. Let's do this one last. Opening the new position. And first we close a lot of stuff. So this is different here. And here we have go up with a price, close a long position because that's the winning position. We go down, we close short positions. So here, I just go one down here. And here we go just one up. We want the digitized price though. I think. I wonder why I didn't just get a bot, find a bot, and why I didn't just run an existing bot. Maybe there's no answer. I believe in my own bots more. I think I get more reward if I make my own program. For reasons. Whatever. Oh, I actually did this already. Okay. Sure. I hope this get rid of these open positions. In a corridor of size 5, I think we should have at max 5 or 10 open positions. I think actually only like 6, I think. Corridor size 5 means we should have 6 open positions max, I think. Okay, yeah, and the position has to store its amount, definitely. It's a little crypto amount. So we could close it again properly. That's what the platform needs to close the position. The current corridor is like empty. Oh. What? Is this minus infinity? What was that? Interesting. Oh, 0 open positions. It closed all its positions, but it's not correct. Actually, that part is just not correct. Yeah. Okay. We need to introduce some test cases, I think. Okay. To close. Actually, this is a lot easier. We can use P1 here, which is the last price. Last digitized price that we had. Closing winner position. Out. We can actually have a log file for the algorithm itself. That makes some sense. Log. Okay. And print also. Okay. Well, there's that. Yeah, it's closing all its positions, which I think is not correct. No, it's not correct for sure. It's not the idea. Also, this funny number. What is this? What is this number? Is that what infinity is? No, of course not. Okay, so far we have our two opener positions with profit plus 0 and minus 0. Now we have crossed the first line, I think. Have we not? 0.01%. No, it's not registering the price change yet. Yeah, we need to feed this with some demo data. And so just check the algorithm. We can't wait for Ethereum price changes every time we change the algorithm. That's not sustainable, even though it's cool. Come on, Ethereum, move. Move, damn it. I need profit. .013%. Oh yeah, it did something. Okay. It closed one. That's okay. Okay. It was going up. The price was going up. So when it goes up, it opens short positions. That's the nature of this algorithm. It always opens positions in the backwards direction. It always hopes for the trend change all the time, basically. We're still going up. We're still making shorts. It's all fine. Corridor is extended. You could calculate the actual corridor size in steps here. Corridor size 0.04. We can calculate that back into cells, actually. It should be like 4. It's 4 cells. Okay, but it has closed all its open positions. That part is actually truly wrong. Yeah, I think as soon as the movement changed, as soon as we went down again, It said, oh, I can close all of these shorts. Or how does it work even? I mean, it's rebuilding the corridor. It's not all bad. How did these get so much profit so quickly? Maybe our cell size is just so small that sometimes it jumps over it and just closes more than one position at once. I wouldn't even be surprised. Yeah, but it has closed one with minus. That's kind of nonsense. Unless it was because the corridor was too big. No, I don't think so. Yeah, we need some test cases for this. And I think I'm done for today. Oh, what a session. Getting pretty close though. So next time we make test cases. And then we connect it to the platform and then we trade and win a lot of money. Thank you. Goodbye.